Welcome everybody to this new session of the Switzerland AI community. I hope that also online you can listen. Please, if not, you can offend Nico, which is managing the audio. So welcome to this new session. For those who are at the first time, we are a non-profit organization which organize events every 2 weeks. And if you want to keep updated with the events or the video that we release after the session, here is a QR code which leads to the website. And from the website, you have access to other channels, like we have LinkedIn, where we post the video, YouTube as well. We have a group in WhatsApp where we keep everything up to date with the new session and so on. So if you feel like to join, please do it. And what else? So the session will be 30 minutes where the speaker will present his use case on AI. Then we will have questions, space for your questions. And at the end, we will have also networking with some foods and drinks that you can enjoy and exchange your ideas, ask further questions to the speaker and so on. So, but now we can start. So today we have the pleasure to have Elliot, from co-founder of Ogram, which will present how to optimize your startup. So how you can see your startup as a model and optimize through the use of agents. So Elliot, to introduce the topic.
Yes,
so welcome.
Thank you very much. So thank you everyone for coming. So I will speak in English. I think it's normal here. If anyone wants to ask questions in French, also at the end, I would be very happy to speak French. Thank you for the invitation. So again, the topic of tonight, your company is a model. What happens when agents start optimizing it? I think was actually proposed by Carl on the basis of something I sent him. So it's not exactly how I would have put it. But we will talk about, of course, we will talk about AI, we will talk about agents, and we will talk about optimizing companies. As a disclaimer in the beginning, so I didn't know what kind of audience I would meet tonight. So Carl respects your privacy very, very strongly, because he didn't share any of your profiles. So he just told me that it was a mix between people that were more technical, some that weren't at all, some that didn't even use AI, maybe, if those people exist. So I tried to do something balanced, but I would be very happy again to dive into more details about the technical side if people want to ask anything about it. Also, he didn't tell me if it was supposed to be promotional. I didn't think so. So I made something more thought-provoking about what we are dealing with on a daily basis. But if you're interested in what we do as a company, I can also answer a few questions at the end. So the title, The Path to Computational Know-how. So how do we make what we call expertise, human expertise, know-how, things that you've took decades to build? What do you know about your market? What you know about your own economic situation? And how do we turn that into computers? So first, I will start with a personal anecdote about my father, actually. So he used to repair computers for digital equipment corporations. So he's an electrical engineer. So he worked in the 80s, 90s with DEC. And I think everything was all fun and games in the 80s when he had to travel around the world to repair computers, and he was an operator. So he got to fly on beautiful planes. He got to have all his holidays paid by DEC until teleoperation arrived. So literally killed his job. So at the moment teleoperation arrived, you just had to call an operator, and you did the manipulations on the computer by yourself. So you didn't need any expert anymore. And I think here the lesson learned is most humans, so not us maybe, but most humans prefer to keep their distances with computers. So if computers can run somewhere and do the processing of the data, but they don't have to touch it, I think they will go into this direction without any hesitation. And I think it's the direction in which we are going with AI. So our first mistake as a startup, we are very early. Again, it's a disclaimer, but we are very, very early. But our first mistake was my first client, and I think Jeff Bezos in this interview tells it clearly enough, always listen to your customer. It's the first thing you need to do is listen to your customer. And my first customer, actually, so 3 years ago, something like that, when GPT just arrived, he's a lawyer in Geneva, and he really came to me and told me, you have to help me encode my know-how. I have an expertise. I know a lot of things about the market in Geneva, in Switzerland. I'm super sharp on certain subjects. You have to help me encode this know-how, make it computational. And I, with my ego or whatever you want to call it, I was like, well, yeah, okay, it's interesting, but I think all the lawyers in Switzerland, they need a tool, a platform, something that they can do business with. And I wanted really to create a platform for all of the lawyers. So I didn't listen to my first customer, and you'll see that we had to go a full circle to come back to what he had in mind at the beginning. If we take a little step back on the retrospective of what we discovered in this tech landscape of AI, and here, if you want, I can also dive deeper into the details, but because I think some pieces of information are actually important. Yep.
Do you get to a little bit on the right, because
oh yeah, of course,
it's covering his,
yeah,
I don't know if
of course,
better to move.
Yeah, of course, thank you. So I think if you go down to really the fundamental pieces of what we are experiencing today, it really boils down to the fact that LLMs, so large language models, are the steam engine, the electricity. So everything boils down to the large language models. I think it's an innovation in the landscape of computer science that we weren't prepared for this, really. I think you worked in natural language processing for a while. So a lot of people during the last 10 to 15 years put a lot of investments into a lot of fields in machine learning, so computer vision, automation, and so on. But natural language processing was always kind of a poor child in this ecosystem until large language models came in 2023 with ChatGPT. Really, it was a breakthrough, but also before this with GPT-2, 2.5, and so on. And I think everything circles around LLMs. Okay. I still can really wrap my mind around the fact that those models can spit out text, but they not only can spit out text, but they can also spit out code. And I think this is the place where no one was prepared really for this kind of revolution, because when large language models started producing sentences that made sense, I think everyone was like, okay, cool, it's a new tool, we can do a lot of things with that. So I mean, all of the sectors of the industry that are concerned with language in some way or another will be impacted by this revolution. So that's what we thought really at the beginning of the ChatGPT era. And then we started noticing that they were also able to produce code, so software languages. And this kind of changed something, because we were like, okay, so this code can now run. So ChatGPT can produce code, but the code can run. So basically, ChatGPT can control the computer. So this was the end game, the end vision. And now it's a reality. So you can have LLMs producing code that runs computer. So you have, like, again, full circle where computers are being operated by AI agents. I think it was clear from the beginning for enterprises like Anthropic, OpenAI. I think they obviously understood this day one. Okay, if an LLM can spit out code and code can run computers, this means an LLM can control the computer. So they understood this day one. And now, if you look at OpenAI, for instance, it's really not hard to see that they are pivoting. They are shifting all their economics to their project called Codex. So the lead engineer is a French guy, Thibaut Sautiot. And if you look at the hiring at OpenAI, all of the huge brains, all of the good computer scientists from the Valley, they all go to the team Codex. They also brought recently Astral, which is a Rust-based Python tool system. So meaning they really want to go down into the layers of the machine. And also Anthropic, of course, they had this computer use already, I think, 2 years ago. So they understood this. It's not even a question, I think. And like everyone, 2 years ago, 3 years ago, we started wrapping things around the GPT, around OpenAI. So if any of you has experimented with this, you will obviously recognize the image on the right. So a role system, you have to give it instructions, then user, and so on. We used to actually even sometimes put our hands into those lines of code. Today, obviously, no one ever writes these kind of systems anymore by hand. But I mean, we started as a GPT wrapper, so just calling the OpenAI models. But I think we wanted to build something. We wanted to build something more, how do you say, like ambitious than just like wrapping things around ChatGPT. And we understood that everything we did just calling a model wasn't sufficient to keep an edge over those big companies, so the Anthropic and the OpenAI guys. So we wanted to understand the things a little bit deeper. So we dove deeper into the technicalities of all of this. And on the right, you have Cursor, which is, of course, a tool all of the developers, again, used to play with maybe a year and a half, 3 years ago. But again, it slightly disappeared because Cursor is still a tool that you use as a developer if you need a front end, if you need something to interact with, if you need an interface. And I think interfaces are quietly disappearing. What you have on the right, on the left, sorry, are a few things in which we had this deep dive. I just want to mention a few of them. So, for instance, what was super interesting, and if you really want a name, you have to Google afterwards. It's a Continue, a project called Continue. I think it was a team from OpenAI that kind of spin off this Continue project. And actually, they were the first to develop this RAG-based code-based indexing. So they used to vectorize all of your code base and give you access to it very quick. And Cursor actually started just as a fork from Continue, because Continue was an open source project. And I remember being furious at the Cursor team because I looked at their product. So they just shipped a VS Code fork with the Continue embedding system inside of it, and they started selling it really to customers. And I was like, come on, guys, you just forked this open source project. But I think this game continues endlessly. And what they did was actually, instead of having your embedding stay on your laptop, you just put your embedding on the cloud. So it ran much faster than Continue, and they had a product. They had something that was better than the open source project. So we got into this, but again, we were like, my God, retrieval augmented generation, it's such an over-engineering thing. You can be much more radical and much more low level, and you can just give access to the LLM to your computer. It can emit Bash and Unix commands. So why can't it control your file system directly? So we started digging into this problem, and we understood that if you just gave access to all of your computer to the LLM, it was much more capable of diving into your file system and finding things interestingly than if you started doing RAG, embedding, vector indexing, and so on. So all of this was over-engineering. Just to give you a concrete business example of this. So sorry, it's the most technical slide of the presentation, but just to give you a more business-oriented explanation. So at the time we were exploring this, we had competitors that were just proposing for the customers. So for instance, legal practices, lawyers in Switzerland, they were proposing RAG-based solutions. So you just take all the documents of the lawyer, you just vectorize it, and then you do an intelligent search engine on your file system. And at that time, we were like, okay, so if you give an LLM like GPT-4, for instance, at that time, you give the vectors of your file system, the results you have is like, I don't know, 20% accuracy on super big data sets, like, I don't know, 20 gigabytes of unstructured data. The results that RAG-based systems were able to produce were like, I don't know, 30–40% accuracy on complex data. And we tried a small experiment. We just gave the LLM full access to the file system of the lawyers. We just gave it like bash commands. So you just navigate through the file system, you just print things. You are totally autonomous on this. And we ended up having like a 90% accuracy result on this, because the LLM just was able to freely interact with the computer. This was already a year and a half ago. So we were like, okay, this is crazy. You can't. And today, a lot of services, a lot of SaaS, a lot of platforms, a lot of products still make their bread and butter on RAG system, on RAG. So it's completely crazy. But yeah, this is another question. So we wanted to go deep into the subject, and notice that we still haven't talked about client really. So I'm again experiencing the same mistake as Jeff Bezos already told us. But this is because I think this is because the revolution is actually deep it's quite brutal in some sense. So what I mean by that is, if you don't take enough time to understand where the forces really are in this artificial intelligence revolution, if you don't take sufficient time to really position yourself as, we are building this block of the ecosystem, I think you can just get wiped away in a few months, in a few years, by a new Anthropic, by a new OpenAI release. So that's why we took so much time, so much effort. We put so much resources into this game of cat and mouse to say, like, what's the real added value that we can add to our customers. And we are starting to find it. The obsession with value was framed like this. So we wanted to give our clients best money for their best value for their money, and maybe we missed a lot. I mean, I'm absolutely certain of that. We missed thousands of opportunities because people were just saying, yeah, but I mean, 20% is already enough, so just give me this. And we were like, yeah, but we don't want to ship a RAG-based system when we know that file system is much more efficient. So we cannot give you something, put something in your hands when we know that we can do better. Some competitors took other strategies, and some of them took the first mover strategy, where you just ship something, it's good enough maybe, and you just have client lock-in, and you wait for the customers to be trapped into your ecosystem. And we just didn't want to create another SaaS. So again, and something shifted, because the public attention suddenly shifted with OpenClaw. So around autumn of 2025, and around now, if you're a little bit late on the news. But what was the OpenClaw revolution really? It just showed the public, it just showed the people that if you gave total access to a computer remotely, you had the best possible world with AI. So you just spin up your machine, just spin up a computer, you give it full access to the data, full access to any type of internet connections you want, so you can go in and out with internet. And then you just set up a remote controller, WhatsApp, Signal, any messaging system, and you have best of both worlds. But what happens now is the computer is getting operated by a remote operator, and the computer becomes the black box. So really, what you have then is you just give it an objective, just give it a goal, a mission, and you just let it run by itself. And this was our vision from the beginning. We were like, okay, we know that the future is no one will use keyboards or mouses anymore, because you just have systems that can process information remotely, and you just give them objectives, just give them missions, and you let them run. So now we had this question anytime we presented our product, and I'm sure some of you today also experiment this, but what is it? What do I get in front of me? What's the interface? And we had this question a million times, like, okay, how do I interact with the product? I think this is a generational bias. I think it's the same as what Steve Jobs presented when he presented the iPhone. Remember, he was saying like, okay, so all of these phones, they have a problem because the interface is blocked. So if you want to develop an app, you have to develop it for these keyboards and tools and so on. So we just want to shift this, and we don't want interfaces anymore like this. We just want a blank screen, and anyone can develop the app with the buttons and the tools that they want. So this is what we are trying to to say when people ask us, what is the interface? The interface is nothing. It's just a terminal. You can ask it question via a messaging system, via email if you want. You can call it if you want. So OpenClaw does all of those things outside of the box. And then came this tweet from François Chollet, who's an ex-Google, and he framed it exactly as we wanted. So sufficiently agentic coding is essentially machine learning. You just set an optimization goal, and you let the model run by itself. So don't worry, we are arriving at the business problem part of the presentation. You give the computer an optimization goal, and it figures out how to optimize it. And this is the future. The infamous black box that you all heard about when talking about machine learning, you just throw resources, compute at a problem, you just give it data, you define the objective that you want to optimize for, and you just throw resources at it. But here, we start with the what does it mean for businesses? What does it mean for real enterprises, for real businesses? And actually, the problem is human. Because humans, they live in an irrational space. So the physical world, it follows some rules, the laws of nature. Actually, Yann Lequin made $1 billion on this bet, so you can encode the laws of nature into computers. Okay, maybe. Actually, information, so languages, mathematics follow logic. That's why LLMs are so powerful. But human beings, they don't optimize for logic. They optimize for really strange things, actually. So this is super interesting, because now you have a computer that can run autonomously based on an objective, and you have humans that need to define objectives that correspond to their reality. Because when you're, for instance, in the real estate business, and your goal is to source new deals, or it's to have a correct mapping of the ecosystem for future deals, what you're trying to optimize for is something you know by expertise. Because you know, okay, I know that when these kind of actors make this kind of moves, this signal, I know the conclusion is this one. So I have to position myself. But this is not rational. It's human expertise. It's what we know by having experienced one domain for a sufficient amount of time. I have a good example, I think, with McKinsey. So what do you think McKinsey sells to companies? Does it sell data-driven decision? Supposedly. But what it really sells is, if you're an executive in a big corporation, you don't want to be the one that chooses, we have to fire 5,000 people. You want to rely on McKinsey to tell you, okay, we've run all the data, and so now you can take this decision and say that you were, how do you say, like, supported by a big council corporation. So this is an example of, if you're thinking logically, you think McKinsey can be disrupted simply by having computers run processing data and giving data-driven decision. But you forget something. It's that the human reality doesn't work this way. So it's not as rational as a computer would want it to be. And this is the goal. You need to design cost functions. So I'm sorry for the machine learning jargon. I wanted to have something that was a little bit specialized also, but anyone who worked with machine learning understand that what we call cost function is the goal you're trying to optimize for. So your objective, really. So what are you trying to optimize this system for? And actually, in the human reality, you need to design cost functions for realities that are not absolutely logical. And to design this cost function, you need really good expertise, domain know-how of one specific domain. You need to know how information flows inside your ecosystem. And this is what human beings that have spent decades on specific problems tend to be super good at, because they know what to optimize for. And this is a problem space description. It's cost function design, and it's applied to humans. If you also have a little bit of background in machine learning, you probably heard about the Richard Sutton bitter lesson thought experiment. So the idea is every time anyone specialized in the computer science field tries to design a problem space with super high sophistication, every time you just throw more compute at it, so you just put more GPUs running on the problem, and you get a solution finally. But with human, it's a little bit trickier than this, because you cannot brute force things that are optimized for human beings, because human beings are illogical. And this is where humans are important, and this is what we understood at that time. So of course, again, I have to do a little I say like amende honorable, when you kind of acknowledge for mistakes you made. Of course, when you're, so this is the famous saying, to a man with a hammer, every problem looks like a nail. To a man with a Turing complete computer capable of running on its own, every problem looks solvable. So I think this is what anyone interested in AI for the last 3 years and trying to build a business over AI has experienced, is that the possibilities of this new revolution are so immense. You can almost tackle any problem in society and say, okay, we will find a solution for this. And I think this is a mistake we made very early on, that we thought we could go to any expert in their domain and tell them, okay, we have a solution for what you've spent decades trying to understand. So if I get back to this slide, of course, this is where humans are important, and this is why expertise and know-how over one domain is to be taken seriously, because of course we now have computers that can run autonomously and compute any amount of data, find any possible data on the web, really process any amount of data. This is what we need to understand. But again, what data is important? Why is it important? What patterns are you looking to find into your data? Why this pattern mixed with this one becomes interesting? And you can go on and on this topic. The know-how, the knowledge of the domain stays absolutely crucial, and you cannot bypass it. We can, of course, imagine that more compute thrown at the problem will start resolving it on its own, but I think it's a mistake, because if you take like a domain really specialized, like I don't know, like merger and acquisition, for instance, okay? You have to process the problem space in merger and acquisition is quite vast. You also have different phases when a deal starts, so the deal flow is in multi-steps. And for each step, you can go down a rabbit hole of endless possibilities you can optimize for. So if you just throw raw compute at huge amounts of data, you will have agents that will start going into rabbit holes, and you're not absolutely sure that the rabbit holes in which they will go are any interesting, so are anywhere from really being interesting. So you will just spend money, you will just spend token money on problems that you are not really able to know if they're interesting. So what Ogram does really under the hood, so I'm starting presenting what we do actually, is to separate what humans are good at from what computers are good at. And actually, it's not the same. So a lot of people think that humans are processing machines. They are not. So there's a debate in the press or on the television or whatever. Are these systems more intelligent than humans? I mean, who even asks this question when you are confronted to AI agents? Of course, you can define intelligence as, I don't know, reactivity to the environment of the world, or agility, like Yann Lequin likes to say. But I mean, if agility is intelligence, I think we are mixing products also. I think intelligence has something to do with information processing. Human beings thought they were well, they were actually until now, but thought they were impossible to defeat on this subject, and now they are. And I think we just have, it's like Kasparov when he loses his first game against the computer. He doesn't want to acknowledge it. He's like, no, that's not possible. There was a mistake and so on. And now, 20 years, 30 years after that, anyone, no one would agree that a human being can beat a computer. But now we are at this moment. So computers, they are good at information processing. And humans, they are good at judgment, relationships, instinct, finding patterns but reactive to data that they have under their eyes. Sorry. Just an anecdote here. Again, I was advising a little cabinet who was doing psychological assessment, and they asked me, so how can we use AI, for instance, in our day-to-day? And I was like, just describe your current process. And they told me, for instance, when we are running an assessment, we take a lot of notes by hand. I was like, okay, this is already something, okay. And I thought the notes were taken on the how do you say, like the movements, or things that humans are super good to capture, like how do people behave, what's their look. No, they were transcribing what people said in the room. So it's like, okay, so you are not looking at what humans are good at identifying compared to robots, but you are actually transcribing what people say, which is absolutely trivial for a computer to do. So you just put a memo, a voice memo on, and it's done. So this is super interesting to kind of separate what we are good at and from what we are not. And we had a solution looking for problems. So as anyone in AI, I think, we finally found the problem space. So what's the problem space for us, at least? Because at some point you really have to deep dive into one subject to become interesting in it. And what we found, I think it's a little bit by luck, a little bit by chance that we found this problem space, but it's where transaction happens. So merger and acquisition company side or real estate, because it's super information intensive. So the more information you have, the better you are. Information asymmetry is key. So you can always go further into the information you have on a specific deal, and more information will never be a mistake. So the more information you have, the better you are. So machines are super good at processing a lot of information. And also super interesting, there's a super clear distinction between what humans are super good at doing: dinners, coffees, talk, advising someone, consulting someone, just like doing business strategy, compared to what humans are not so good at, like due diligence, like crunching a lot of data, really processing huge amounts of data. And this field is super well balanced on these different aspects. A deal maker is actually an algorithm, because he knows some patterns in data are interesting. He knows what to optimize for. He knows where to find the correct information resources. And he knows that there are some weak signals that you have to look for. And what does it look like? So again, the question that anyone will always ask us, so what does it look like? And again, so sometimes it just looks like a PDF. So maybe it's the most unsexiest thing to say after such a talk, but most of the time, information you need is only information. So it can have any form you want. A PDF is a good form. Again, I have an anecdote on this. One of our clients, he wanted like market intelligence, super strategic market intelligence. Can you tell me exactly who the supplier for this manufacturer is? So he wanted a super specific information. And in the beginning, we designed an anagram system for him. So we passed a lot of information, we cross-referenced it, and so on. And the end result we had was, again, a super long LLM style report, like 15 pages about everything. And I mean, our client is quite old. He uses a Monoc to look at his phone, so he has to zoom in ChatGPT 15 times to read an information. And with my co-founder, we were like, look, are we really going to send him like a 15-page memo about his question? No, his question is just like 2 words, the name of the supplier. So we just send it to him by message, actually. And we were like, yeah, this is the information he's looking for. So sometimes it's a PDF, sometimes it's just even a message. So on any messaging platform you want, because in the end, it's just information. How do you want to read it? How do you want to consume it? It's just up to you. I mean, you can want a dashboard, you can want an email or anything. It's just information. So this is what we are creating, and thank you again a lot for your attention and your time. I hope it was interesting for you to follow, and please, if you have any questions.
Thank you very much. I have a question regarding RAG versus computer file system. To me, computer file system is just another database type. It just has a different query language, which is Bash, right? But what about the data granularity in this case? With RAG, you have a certain data granularity. So you have chunks, you have vectors, which represent specific part of data. And with computer, just giving it wild access to computer, it's what if you have a 1,000-page PDF document, and you need to find some parts of scattered along this document. So every time your agent will need to read the whole document in order to be able to analyze this and how to search, etc., etc.
Yeah.
Thank you.
Thank you. Thank you very much for this question. So I get it. So it's a kind of a technical question, but I will try to answer it as easy as possible. But I mean, both sides have their trade-offs. So if you have RAG, for instance, basically what you're doing is comparing the vector shape of your information to the vector shape of the user question. And if it's lookalike, you match it and you say, okay, this is comparable. So I think the information the user is looking for is here. What's good here is that, of course, you can parse a lot of data super fast because it's just like vector comparison. But what's not good is that if the question is like, where can I find elephant, for instance, the shape of the vector is highly influenced by the word elephant, because elephant is one vector in this vector space. So you will find everything that's close to animals, to elephants, and so on in your data. So this can sometimes be a good thing. But if the question is like, what happened on the 4th of July, you will have a lot of also candidates for the vector shape that are not so relevant. You really want to find facts that happen on the 4th of July. So you have trade-offs. And then again, I think what we experienced with this was that it's not black and white. If you give terminal access to your computer, you can also give it access to other types of tools. So you can also give it access to a small Python library that does NLP on your computer, for instance, SAIC or anything. So you can actually have the best of both worlds. I think it's not RAG versus file system. It's don't stay stuck in the RAG ecosystem. Get as close as you can to the full computer capacity, but then give it access to the correct tools for the problem that you're looking to optimize. So I think if it's a matter of balancing both.
Are you now getting back to the first slide of helping your client from a couple of years ago to improve expertise? And if so, how does Ogram do that? Because what I hear is that, okay, so NetLM and very good at computational power, throwing, treating an information. But the expertise that sits in the human brain, it's not on the computer. So how do you help? How does Vaucher help to encode that expertise and to do what?
Yeah. Thank you so much for your question. So I have multiple steps to answer, but first, I think we're at the beginning. So we haven't. I think it's the dream of any startup to already have the product on day one. So we more approach this as we have found the problem space, and now we are building the methodology step by step to do it at scale. Okay, but today we are very close to a service company also, because we spend time with our customers trying to understand what business they're in, what they are doing, and so on. But we already have hints of how we can automatize that and make it scale. So what you need to find is places where there is high value information in the client ecosystem, and you can look at, for instance, mailboxes. So a lot of your expertise transits through your mailbox, for instance. So a lot of things, a lot of the patterns that you use on a daily basis transit through your mailbox. Another one could be recorded conversations you had with your customers or clients or anything. Another one could be, for instance, just looking at the information ecosystem you have on a daily basis. So, for instance, someone who's in the real estate business, he'll always look at the mutation in the, how do you say in English, the commercial registry. He'll look at the FAO, so all the publications he needs to look at. So you can find expertise also here. But a lot of things today are done by hand, meaning we spend time with the client and we try to understand via interviews, anything, we try to understand what he does. I think at some point, what will become super interesting will be when we'll be able to have enough data about what the client does on the daily basis. So, for instance, have access to all his archives, that we can even find patterns in his expertise that the client doesn't know about. And I think this is the moment where it will become very, very, very interesting. Because today, it's like, how do you proceed on your market? Okay, try to understand this, to encode it. But tomorrow, I think it will be, actually, we can tell you that why you did this deal 2 or 3 years ago that went well. It's because such and such information collided, and you didn't even know about it, actually. So, yeah.
Yeah. Thank you for the presentation. Very interesting. My question is about data engineering. How accurately can AI agents automate this data engineering and preparation of the data process?
Yep.
All this extract, transform, load. I mean, we saw that, okay, you can give it PDFs, CSV files, all kinds of raw data, but then can it really replace the entire data engineering process, or do you think this type of work is still necessary to get it very accurate? Because once it has the data, sure, it can do all kinds of insights and data science and stuff.
Yeah.
But how accurate is that preparation, transformation part?
Okay, so again, super interesting question. Thank you. I think today our role is heavily to babysit these agentic systems. I mean that in the sense that you throw an objective at them, you say, okay, try to do this on your own, okay? And you just look at the logs and you're like, ooh, what did you do here? I mean, you tried to fetch the information on this site, but you didn't get access to it because of a Cloudflare block or like a CAPTCHA even so. And so you look at the logs, because you see the result, you're like, oh yeah, he found all the information we needed, okay. And then you look at the logs and you're like, but actually you just made it up because you had like Cloudflare blocks at each step. So you kind of have to babysit them to do the data preparation today, okay? But I think this is a problem that will be less and less important in the future. But I think you have to babysit them for the moment. And again, the other thing, sorry, this is the thing that I wanted to say. I think one of my eureka moment for the metaphor of just throwing compute at a problem and just letting the computer solve it was actually when I was trying to do something like that, playing with Cloud Code or whatever agentic harness. And actually, I was designing the problem space myself by hand. So I was describing every step Cloud Code had to do to get this information and use this or that proxy. And at some stage, I was like, maybe I'm just over-engineering it. So let's just throw the optimization problem at him. So just find a way, the best solution to give me this answer. And actually, it found the steps on its own. So sometimes even these agents, they are crazy enough to just like Google something before they start working, you know? So there's just like, okay, I didn't understand this user's question, so I will just Google where he asked me, and oh, okay, I see this Stack Overflow problem, so they tell me that data preparation needs to be this or that, and so they kind of figure out the way to do it. So I think this is a beginning of something that will generalize in the future.
Hi there. Thank you so much. Really fascinating presentation. My question is on the boring side, I'm afraid. It's if you are giving an agent full access to files within an organization, how are you handling data privacy and data governance issues? Because obviously there's data that's restricted within organizations.
Of course, yeah. Thank you so much for this question again. I think today, we are making a business decision about that. We don't go to big organizations because of this data siloing problem. I mean, there are many other reasons why we don't target big companies, but this is maybe the major one, because the data access is scattered. So it's really a problem. I think this scattered data access for companies is just a legacy issue, because I mean it was made at a time when you had humans operating on data. So, but of course, it's absolutely impossible to imagine in a big corporation where you have like siloed ecosystem to just run an agent at scale. I think it's one of the biggest Microsoft problems at the moment, really. If you look at them as how do they navigate this revolution, because they made their last 20 years on siloing data for companies. So now people are asking them, can you have the same power as Cloud Code? And they are like, no, we can't, because actually all your data is scattered, so you don't have that access to this and that. So I think it's actually a big problem, but we don't target organizations that run like that for the moment.
So they have the copilot working in the organization, which doesn't have access to anything.
Exactly, yeah. And Copilot is, I mean, it's so funny because there are thousands of memes on Copilot on the internet, because it's just not as good as their competitors for multiple reasons, actually. If you look under the hood, it's also the problem that Anthropic and OpenAI, they also started the agentic harness race like a year and a half ago, maybe 2 years, and even more if you are into their strategic decisions. But they started understanding that the value was not the LLM itself, not alone, but it was the guardrails that made the LLM capable of manipulating a computer that had value, really. And I think Microsoft were just not seeing this opportunity. I don't know why, actually. Well, maybe it's an error. But, and so now Copilot is way behind. I mean, they will catch up, that's for sure. But in how long and at what cost, I think it's a question. Yeah.
Yes, a general question. So you mentioned a lot.
There is one question with the microphone, and then we'll.
Oh yeah, okay, no worries.
No, I just had a question. The New York Times is taking ChatGPT to court, right?
Mm-hmm.
Because ChatGPT are scraping their data.
Yep.
And at the same time, Cloudflare are also looking into building a marketplace for data.
Mm-hmm.
So to what extent are we in a world today which is a bit like the pre-Spotify age, whereby everyone's grabbing everyone's data for free, but there's no real democracy around who can share what, and
you know, who can have access to whose data? You know, have we evolved past this sort of anarchy situation where, in theory, AI is going to just take over everything, or actually we're going to go back to a Spotify world whereby you'll actually be able to sell your data, not just steal data through LLMs?
Yeah, I think it's a fascinating question. Thank you so much. I'm quite surprised actually that actors that currently put data into the public space. Look, I'm thinking, for instance, the corporate registry or the FAO and so on. They don't have huge blockers on their data. So essentially, what they are doing is they are paying for user requesting their data because it's a public service, and so they're paying for it. But once, I mean, like it's already starting, but I mean, in a few weeks, in a few months, when you will have swarms of agents requesting resources from your servers, you'll be paying huge costs to even only put the data in the public space. So I think this will start raising the issue that you highlight, is that these will start blocking access to their resources and maybe monetizing it in some sense. And I think the second really cost and usage problem I think that your question is also raising is that today we are living in a kind of a free lunch scenario, which is absolutely not possible at long term, where these companies, they kind of throw compute at us to make us dependent on their systems, for instance, OpenAI, Anthropic. But the cost of running long agentic tasks on GPUs is absolutely real. I mean, it's thousands of francs for a few hours run. So what will happen, again, in a few weeks, in a few months, is that you will not be able to say, okay, this is my problem space, and now I will just put Claude Code for 10 hours on this problem and make it run, and he will just solve it in the end. You will really have to pay a price for this. So this is also where engineering will re-emerge, will become relevant again, because for a 10 hours run, and also when you have blockers on the internet and so on, you really have to engineer the steps the agent has to take to solve the problem in a way that is smart. So you have to have clever algorithms for data parsing, segmentations, and so on. You also have to use the correct libraries. Again, why did OpenAI pay so much for utility service? It's Astral. You saw the news maybe a few days ago. So Astral, they are building Python tools coded in Rust to be more efficient, basically, I think. And Astral and OpenAI paid a huge price for that, because reliability and speed will become essential when you will have like super long running tasks. So I think some of the things that today seem to be free will definitely have a cost in a few weeks, in a few months, and people will start realize, oh, okay, it wasn't free to scrap all this internet data, for instance.
Probably they're using it for free for 11 their machines and to get a day. That's what they actually do now.
Of course, also, yeah.
We'll pay for free, pay with the data. You
Of course, definitely. But I think also to kind of make us addicted to the raw power of these systems. I mean, for instance, if tomorrow you just have like no Claude Code, no Codex, no agentic AI anymore, I mean, what are we going to do? I mean, all the economy relies on these systems now, so we're getting addicted to it. Yep.
Yeah, so a bit general question. So you mentioned a lot of good things about AI agent. So in your perspective, what are the limitations of AI agent, and what are big like risks at this stage when we use it?
I mean, so there are two questions. So limitations and risks. So I will start with risk, because I think it's quite obvious. I mean, even in the conflict that is happening in the Middle East, I mean, anyone who reads the news understood that Anthropic had an ethical dilemma because their tools were being used by Palantir, who are selling information services to the United States Army. So, I mean, this is already obvious. So if you have super powerful agents and you have the budget that the defense can have for the army, you can kill people with this system because they just basically give you the information you need to kill people. So this is the business of Palantir actually. So basically, so I think the risks already are quite obvious. If you give super powerful intelligence to people who are in the kill industry, it's a mistake. But then you have the limitations, and on the limitations, I think I wouldn't. It's a bit thought-provoking to answer like this, but I think I wouldn't frame it as a limitation problem. I think they are limitless. So what I really think is like you just close this computer, you never touch a keyboard anymore, and you just like ask computers to process huge amounts of data to give you the answer you need. And in this sense, I think they are quite limitless because everything computer can do, these systems will be able to do. So it's quite limitless in that sense. But the limitations will be the cost of this, actually. Basically, it will be a cost limitation. So when you say, okay, now please do a super long agentic run to crunch all the data that exists in the world about this specific market problem and cross-reference it with all this data, you will end up with a task that will cost you like 10,000 francs, for instance. Like 10,000. It's not even...
Actually, that's the reason, like when you run on a personal level. But
yeah, I think it was more of a limitation, so basically the cost. But the risk would be, of course, if you give it access to your credit card, if you give it access to all your information, your personal information, this is a huge risk. Yeah, of course.
There is space for other 2 questions. Anybody? Okay. If there are no online questions, I think we can close the session.
Perfect. All right. So before, you have one more question? No? Okay. So before we close, so just a few notes. So we'll have exceptionally another session next week as well, which will take place here. I think the room is different.
It's different.
But we'll do another one. So the theme will actually be like about new startup playbook. So how for tech startup, very similar to actually what you presented today, but more like shipping products and solutions. What it means to actually develop super fast prototypes and solutions in now the Gen AI era. We also want to announce that for around the second half of April, we'll help organize workshops on Cloud Code. So if anyone is interested to learn how to use Cloud Code, either for the first time or use advanced techniques on Cloud Code, this will be a workshop that we'll organize like 4 hours during the week in the evening with dinner included. And also, just to let you know, so now we're expanding a little bit our social community. So we used to start on WhatsApp, but now we also have a LinkedIn that we're growing. We are sharing the pictures, the videos on YouTube as well. We are now starting as well an Instagram channel. And so if you want to follow a little bit more news on what's happening, you can also follow on the websites, everything and the different events. Finally, if there's any feedbacks that you have for us or like interest topics that you want to talk about, or even if you want to speak or you know speakers that could be interested to join, please come talk to us. That's it for me. Thank you again, Elliot.
Thank you.
And we can move on to the networking session.